So we have the sketch below and then a graph of g of x, which is given by the following equation. Okay? And then we also have f of x, which is given by the following. And then the graph of f has a turning point at A. Okay? The graph of f is turning here at A. And f and g intersect at A and B. So these two graphs, they are going to intersect at A and what and B. Okay, number one, Masitana, they say calculate the numerical value of k, the y value at A. 5.1. How will you go about doing that one? Yeah, they gave us x. Yeah, let's write the point. So we have 3, which goes with k. Okay? Sure.
And then 3x.
Yeah. Yeah, remember, I think they're saying here g of x. A is a point on g of x. Okay. So meaning which we can say which we have g of 3. Okay? Everywhere we see x, we're going to put 3. And then we have minus 3 open brackets multiplied by 3 plus k plus 20. But now we know what when x is 3, what is y? When x is 3, what is y? When x is 3, what is y?
K.
Yeah, so you can come and say k is going to be equal to minus 9 plus 20. Okay? And then it says if you type this in your calculator, what you get? 11. So how are you going to get your marks here? You're going to get 1 mark for substituting. Okay? Substituting k and 3, and then you're also going to get 1 mark for the answer, and then you get your 2 marks. So you can come and safely say which here you have a point A, which is going to be given as 3 and what and 11. Does it make sense for y to be positive?
Yes.
Okay, it makes sense for y to be positive, sure. And then number 2, they say determine the range of f. They say which we need to determine the range of y is equal to minus f of x. Okay? So we're not looking for the range of this graph. We're looking for the one that is reflected by the x-axis. Okay? So if this thing is reflected by the x-axis, what's going to happen? Yeah, agree if you make y to be negative, it means you are reflecting it by the x-axis. If you reflect something by the x-axis, what happens? There's something which is going to change. Okay?
Yes.
What changes? What remains the same?
We reflect what?
They're saying we want to determine the range of a reflection of f of x by the x-axis. So how do I know which is the reflection by the x-axis? I think they said we have y, which is minus y. Okay? So instead of having y, now you have minus y. Okay? So what is going to change here on this graph here?
It's y.
It's y. Okay?
Yes.
X is going to remain the same, but y is going to become what?
Negative.
Okay, so it means the coordinates of A. What do you expect the coordinates of A to be? We are going to have what?
3 and minus 11.
3 and minus 11. Okay?
Yes.
Now, what is going to be the range of this thing here? I get a graph layer is going to look like this.
Yes.
So what are you going to say about this one? What is going to be the range of this one? Range, we're looking at y, yeah. We're looking at the y value. What is the biggest value of y that you can have? What is the smallest value of y that you can have? So the range is possible y values. So if you come and check here, at minus 12, do you have any graph here? Do you have any part of the graph? At minus 12, do you have, like, let's say this is minus 12, do you have any of the graph? So you don't have, the graph doesn't exist to minus 12. So when do you see the graph here? When did you start to see the graph? Yeah, so I'm going to say y is going to be greater or equals to what? Minus 11. So y is going to be greater or equals to minus 11. We're going to give you 2 marks for that one. Or if you didn't want to write it this way, you can say y is going to be an element from. We are going to start from minus 11 okay, up until we go to what? To positive infinite. Are we still fine then? Okay, let's go to 5.3 then. 5.3, they say we should determine what is going to be A, what is going to be B, and what is going to be C. Okay? Now, how do you determine this one here? It means what you need to determine the equation. Okay? For you to determine the equation, there are 2 equations that we spoke about the other day when we met. We said we can use the following equation that says y is going to be A, x minus x1, okay? And then x minus x2. Okay? Or if we don't use that one, we can use the following equation that says y is going to be A, x plus p, okay?
Squared.
Or squared plus q. Now, when do we use equation number 1, Platin? When do we use equation number 1? if we have x-intercept, okay? So we're going to use this one if we have the x-intercept. Let's come and check here. Do we have the x-intercept? Do we know what an x-intercept is? Let's come and check. Actually, x-intercept, we talk about when the graph intersects with the x-axis. Do you know what is this value here? Do you know what is this value here? You don't know it, okay? So it means which number one cannot work because x1 and x2, they represent the x-intercept, okay? Okay, we can't use that one. If you can't use that one, we can try to use this one. When do we use this one? When we have the turning point, okay? Do we know what are the turning points here? What are the turning points? It's what? We have 3 and 11. So we can come and say which we are going to have y, which is going to be a, open bracket, okay? And then here we're going to say which we have x. Now we need to put a value. What is the value that we can put so that we can get 3 here? What is it that we should put there?
-3.
So we're going to put -3 all squared, okay? Plus 11. I will still find. So we don't put 3 here, but this is the value that we are going to put. So P is the value that we put so that we can get the x value of the turning point. Okay, okay, now we are not done. There's also a point that they gave us. Okay? They said which there's a point that we can use, which is point B. Point B says which we have 6, which goes with 2.
Yes.
So we're going to use that into our advantage. We'll come and say, okay, but now we know what is y. What is y?
It's 2.
It's 2, okay? Which is going to be equal to a open bracket. We have x. What is x? It's 6 minus 3, okay? All squared plus 11. And then you are going to work around this thing, okay? So you're going to say you have 6 minus 3 all squared, okay? 6 minus 3 all squared, it gives you what?
9.
So you have 9a here plus 11, which is going to be 2, okay?
Mister, wait.
Yes. Actually, you have a multiplied by 9 all squared, okay? 3 all squared. What is 3 all squared?
9.
It's 9, Anish. And then you say a multiplied by 9. What is a multiplied by 9? It gives us what? 9a. And then you take this 11, it's positive, you take it to this other side. Okay? If you take it to that other side, what are you going to have? Then you're going to have minus 11 plus 2, which is going to give us 9a. Okay? And then these two, they're going to give you what? Minus 9, which is going to be equal to what? To 9a. You divide by 9, you divide by 9. It says a is going to be equal to minus 1. Then you can come and say it means the following equation can be written as y is equal to minus open bracket x minus 3 all squared plus 11.
Mister.
Yes.
I see
like you can't add these two things, guys. Like I can't say like I can't stress that you can't add this one and this one. They are not like terms. Like Mara, you can't do that. Like in maths, it's
I said like we didn't add 9a plus 11, but instead you said 3 minus 6 minus 3 all squared plus 11.
Yeah, but look at this. This is one thing here. This part and this part is one thing. This thing here is one term. Okay, from here onwards, actually, you're going to expand. If you expand this thing, it says which you have minus open bracket, and then we have x squared. You are going to foil like here.
Yes.
You have x squared minus 6x plus 9 close bracket plus 11. And then after that, you say negative multiplied by positive, it gives us minus x squared. Negative and negative, it gives us plus 6x. Negative and positive, it gives us minus 9 plus 11. And then if you type this in your calculator, you are going to add minus 9 and 11 again. If you add this to what you get minus x squared again. And then you get plus 6x again. These two, they are going to give us what? Plus 2. Ne? The question was asking us what is A, what is B, what is C? What is A? What is B? What is C? And then how do you get your 6 marks then? You're going to get your mark for substituting turning point. You're going to get a mark for substituting these 2 points. 2 and 6 will give you another mark. Getting A will give you another mark. Expanding and giving us the equation will give you another mark. And then we're also going to give you 1, 2. So you have 1, 2, 3, 4, 5, and a 1, and a 6. Next question, it says, determine the values of x for which f of x is going to be bigger than g of x. Okay? F of x is above, g of x is below. We want f of x to be above, and then we want g of x to be actually to be below. Let's go and check when does that happen. When is f of x going to be above? When is g of x going to be below? So we have 3 and then we have 11 here. Now, if you look at this instance here, what will you say about it? G of x is above, okay? And then f of x is what is below. So we don't count that one. Okay? So now what do we want? We want f of x to be above, okay? And then we want g of x to be what to be below. When does that start to happen? Agree here there's an intersection. Can you see that? Okay? And then look at this. Agree f of x is above. G of x is what?
Below.
F of x is above, G of x is below. Okay? F of x is above G of x up until we get to what? To an intersection. Now, when did that happen? This is where it happened. This is the part that is making that to be possible. So I'll come and highlight it and say this is the part that is making this to be possible. Can you see the highlighted? Okay, now you need to come here and say, okay, dotted lines, do a dotted line and tell us what is x here. X is equal to 3, okay?
Yes.
And then what is x here? It's 6, okay? So this thing here is going to happen on the highlighted part. This is the highlighted part. This is where this thing here is possible. What are the x values there? Tell me what are the x values that are making that to be possible? It's 3 up until to 6, okay?
Yes.
And then how would you write that? You can write it using interval notations or you can write inequality, okay? So let's write it as an interval notation. You're going to say you have 3, you have 6, and then you put x in between. And then you say x is going to be greater than 3, but x is going to be less than 6. And then you get 1, 2 for that. If you didn't write it this way, you can write it using interval notation. You'll say which you have x, which is going to be an element, okay? From 3, okay? Up until you get to what? To 6. Still, you're going to get again your 2 marks here. All right, we go to 5.5. On 5.5, they say the nature of the roots. Okay? We want to know the nature of the roots. Are they real? Are they non-real? Okay? So they say, describe the nature of the roots when we have f of x minus 11. If you have f of x minus 11, what is going to be the nature of the roots? There are 2 ways in which you can do this thing here. You can come and write f of x, but that one is going to be long. We can do it graphical or we can do it exactly the way we know it. Let's start with the way we know it. Here's how we know it. We know which we can get the discriminant. Okay? Let's go and get the discriminant of this thing here. If we get the discriminant of this thing, it's going to look like this. So we are going to say we have f of x, which is going to be equaling to minus 11. Okay? And then let's work around with this thing. If we're going to play around with this thing, we know what is the equation. Okay? The equation, it says which we have minus x squared. Okay? And then it says plus 6x. Okay? And then it says
plus 2.
Plus 2. Ne? And then it says minus 11. Okay? And then if you work around this thing here, you're going to have minus x squared. Okay? Plus 6x. Ne? And then if you say this one and this one, they're going to give us what?
Minus 9.
Minus 9. Okay, we get minus 9 here. Now, we need to say what is going to be A, what is going to be B, and then what is going to be C. On this one, what is A?
Minus 1.
Minus 1. Okay, what is B?
6.
6. What is going to be C?
Minus 9.
And then we go to our discriminant. On our discriminant, we're going to have B squared minus 4AC again. And then we come and say, okay, what is B? It's 6 all squared again. Minus 4 multiplied by our A, minus 1 again. Our B, our A, it's minus 9. And then you type this in your calculator. If you type this in your calculator, what do you get? You get 0. So let's try it. It says which we have 6 all squared, okay? Minus 4 multiplied by minus 1 multiplied by minus 9. And then you get 0 here. What are you going to say about the nature of the roots here? They are real.
Real, rational.
And equal.
Yes.
So we have roots which are going to be real and what? And equal. So you could have said these are equal roots. Yeah? So we have roots which are real and then they are also what? Equal. Are we still fine then? Now, in other words, if you wanted to do it graphically, this is what they meant. No? This is what they were meaning, guys. They're saying, would you take f of x? Look at the following. If you take f of x here, here you have 11. Can you see that?
Yes.
On f of x, they say, take this thing here and then you shift it. You are going to shift it 11 units downwards. If you take this thing and then you shift it 11 units downwards, it means what you had 11. If you subtract this 11, where is this graph going to go? It's going to go here now. It's going to go here at 0. Yeah, and then if they ask you, what kind of roots are you going to have here? You're going to tell them, because I'm touching this thing here, once it's turning, I'm touching the graph and then it's also turning. It means the roots that you're going to have here, they are also going to be real and equal. Yeah, because the graph is turning at the x-axis. Okay? If your graph is turning at the x-axis, you have equal roots. It means, in other words, the x value here is repeating itself 2 times. You have x1 and x2 being exactly the same. Okay, we are going to the last one. Determine the values for which f prime of x multiplied by g prime of x, they are going to give us a thing which is greater than 0. Okay, so as I was saying here, we are asking which m of f of x. Okay? Now, how to get m of f of x? You get m of f of x by doing the following. A graph of f of x is going to have 2 m's. It has an m whereby it's increasing, and then it's going to have an m whereby it's decreasing. So a graph like you can do something like this. M, you can just draw a line like this here up until to the turning point. So this is m number 1. And then m, I want you to understand something. This m is positive. Regardless of whether the graph is below the x-axis or the graph is above the x-axis. The m itself is positive. The other m that you have is this one here. You have 2 m's. The other m that you have is this one here. And then this one here, it's negative. How do I know which is negative? It's forming an obtuse angle with an x-axis. So f of x has 2m. It has m which is positive, and then it has m which is what? Which is negative. Does that make sense? So f of x is divided into 2 parts. Remember the other day they were asking us, when is this graph going to be increasing again?
Yes.
Your graph is going to increase if m is positive. If it's making an angle, the angle that it forms there, it's an acute angle, then the graph is increasing, and then the m is positive. And then the graph therefore is going to decrease, starting from here and then up until it gets to infinity, your graph is going to be decreased. Okay. Now, because now we're looking for this here, we want to have positive. Okay? How to get positive? You can get positive by having negative multiplied by negative. Okay? Negative multiplied by negative is going to give you a positive. Okay? Another way you can get positive is if you have a positive multiplied by what? By a positive. If you have a positive multiplied by a positive, it's also going to give you what? A positive. Okay. Now we have the red m is positive. Okay? The green m is negative. I will still find it. Okay? Now, what are this m? This is m for f of x. So I'm going to say this is m for f of x. So we have m of f of x, which is positive. We have m of f of x, which is negative. Now, what else am I going to bring into you now? I'm going to bring m. I am going to bring m of g of x. M of g of x is -3. So m of g of x is -3 is this thing here. So m of g of x is -3. So in other words, it means m law is always going to be negative. The m of g of x is always going to be negative. It will never be positive. It's always going to be negative. Because m is -3, it's not going to change. But m of f of x can be positive, and then it can also be what? Be negative. So in other words, the only situation that we're going to have is if we have a negative multiplied by what? By negative. If we have a negative and a negative, we're going to have what? Positive. We already know this one can only be negative. It can't be positive. Okay? So the only person that we have to go and check, when is this person going to be negative? And then we are down. So we have red and then we have green. When is f of x going to be negative? Red or green? Green. So go green, and we come and highlight here go green. With left or right, it's going to be negative here. What are the x values that are going to make that to be possible? We come and say, okay, what is x here? It's 3.
Yes.
Okay, we come and say, which here we have 3. So values from here, and then we go up until to infinity. Okay? So I'm going to say to them, when x is greater than 3, then the m of f of x and the m of g of x, when you multiply them, they're going to give you what? Positive. And then you get your 2 marks then.